right, well, I trust you did well on your quiz yesterday, or in our last lesson, rather. I'm going to begin a section now in the class notes section of your notebook of unmemorized constructions. So if you would start a new page in the class notes, or what would be easier for you would be to have a blank sheet of paper just sitting out on your desk and plan to put this paper into your notebook later. Again, trying to do constructions in your notebook is going to present a challenge. So my recommendation, go ahead and do these constructions out of the notebook rather than in the notebook itself, in the binder. Unmemorized constructions, the next section that you're going to put here in the class notes. The idea here is rather than me giving you step by step how to do a construction, and then us practicing the construction several times, and then me giving you a quiz over these constructions that you've essentially memorized, I'm going to teach you how to do various constructions. I'm going to teach you the mental process required to figure it out for yourself. Ignore the bell. All right, so essentially, we're going to do every construction once. We're going to do dozens of constructions. And I'm going to pick a few that we have done already, and you're going to do them for a quiz. The plan isn't for you to memorize these dozens of constructions to do them on the quiz, though technically you could, but rather to figure out the process. When you see them on the quiz, it's not so much, oh yeah, I remember doing that one. It's, oh yeah, I know how to figure this one out. And maybe you vaguely remember having seen it at one point in your life. The first thing I want you to write down in doing an unmemorized construction is you want to start with a sketch. Start by drawing a sketch of what it is you're trying to construct. If it's a right triangle, make a sketch of a right triangle. If it's a parallelogram, make a sketch of a parallelogram. If it's a circle, make a sketch of a circle. But make a sketch of what it is you are trying to construct. Make a sketch of what you're trying to construct. Number two, on the sketch, label all of your given parts. On the sketch, label any given parts. So with every construction, you're given something or some things on the construction, on the sketch rather, label what it is you already know. Label what you already have been given. Number three, to start the construction itself, notice we don't start the construction until step 3. The first 2 steps are essentially preparation. Step number 3, start with a long line as base. Start with a long line as base. Nearly every construction will get started with a long line. So let's just plan to get the long line down. You've heard it said before, you know, it's hard to stare at a blank piece of paper, right? So my teacher in English always used to say, okay, it's hard to write or come up with something to write when you're staring at a blank piece of paper. So write your name at the top, and now it's not a blank piece of paper anymore. Didn't really work that well. This actually should work for you. You're staring at a blank piece of paper. How do I do this construction? Well, start with a sketch. Now it's on a blank sheet of paper. Okay, yeah, but the construction still isn't there. Get it started, draw a long line. It's a great way to start. Number 4 is to construct the given parts. Construct the given parts. You will have already labeled on the sketch where the given parts are. That should help you to figure out how to construct the given parts on this baseline, this long line you've drawn. And then number 5, this is the part I love. Determine a way to finish, or I'll say on the board, figure it out. Determine a way to finish. Figure it out. You're going to have to employ some thought. You're going to have to think, what do I know about this? What have I learned about this figure? This section that we're going to spend a few days on basically takes the culmination of everything you've learned all year and puts it into practice of actually making the sketches work. The same types of thought that you would put into a proof, you're going to put into construction, because in a sense you're going to mentally prove this is how this would have to work, and then you actually do it. So this is really where everything kind of comes together. Page 181 in your textbooks, while you have this paper out of your binder, also have your textbooks out. We're going to do a few constructions together. This class period is going to be a little bit shorter, obviously because of the little bit of an unusual schedule we've got going on today. So we're not going to get quite as much accomplished as I normally want to. We have time, I believe, to do several problems together. Page 181. I want you to look at exercise number 2 at the bottom of the page.
Do you want us to do this on the same page?
Yes, the same page where you've got the notes. You're also going to put you're going to start just putting lots of constructions in the class notes section. All right, page 181, number 2. Notice above number 1, it gives you the actual directions. Because if you look at number 2, it says a leg and the adjacent acute angle. I don't even know what to do. Right. So on the homework tonight, don't treat the problem that way. Look above number 1 where it says, Audrey.
Construct a right triangle having given.
And then read that part with number 2, and it comes out saying,
Construct a right triangle having given a leg and an adjacent acute angle.
ah, you see how that all flows together? So it's not just, what does this mean? Read the other part. Notice when you get to number 6, there's a different set of instructions. Well, actually, it reads the exact same. But construct a right triangle having given. Flip the page. Look right above number 13. You see how it says construct an isosceles triangle having given. Right, so everything under that is going to be constructing an isosceles triangle. Look at number 21, 22, 23. Look at the directions there. Construct an equilateral triangle. And then you see numbers 24 through 35. Construct any triangle. You see that? Okay, so don't give me this, I didn't know it. No. Read it and then go from there. So, I'm trying to construct, class, what?
A leg and the adjacent.
No, that's not what I'm trying to construct. A right triangle is what I'm trying to construct. So we're going to start with a sketch. On your paper, go ahead and draw. Well, actually, let's write out what we're trying to do. We're trying to construct a right triangle, and we're given, we said, a leg and adjacent acute angle. Let's go ahead and jot down what it is we're constructing so we can easily remind ourselves instead of having to look back in our textbook. That way maybe you could set the book on the floor open beside your desk. But this is what I'm going for, is a right triangle. So let's draw a sketch of a right triangle. Draw a right triangle. And it says I'm given a leg. Which leg? Well, it really doesn't matter too much which leg, except remember we were going to make a long line that would be our base line? Anytime I'm given the choice, I want to make something fall along the baseline. So I'm going to make this be my given leg. The base leg is going to be my given leg. What else am I clearly given, class?
Adjacent acute angle.
The adjacent acute angle. Which one's the adjacent acute angle? This one up here or the one down here at the bottom? Clearly the one down here at the bottom is adjacent to this leg. This would be the opposite acute angle. This would be the adjacent acute angle. So label this as adjacent acute angle. That's something else I'm given. Technically, there's one other thing I'm given, but it doesn't say. We have to be able to figure it out.
That it's right triangle? No.
Well, yes, but what does that tell me?
Angles, the acute angles will equal each other?
Oh, certainly not going to be equal to each other. No, no, very, very highly unlikely. What else am I given, class?
90 degrees.
That there's a right angle. By virtue of being given a right triangle is what I'm trying to construct. What do I know about the figure? Remember I said it's part of what we're going to have to do. What have I learned about this? Well, I know in a right triangle, I got a right angle. So technically, I also know there's a right angle that's going to be here, don't I? It wasn't specified in the given. I'm expected to know that, right? So if you're told to construct a parallelogram, it's expected that you know opposite sides are parallel. It's expected that you know opposite sides are equal. It's expected that you knew diagonals would bisect each other, right? And if you don't know these things, listen, you cannot do the constructions. You will fail. So you better know your stuff. Or for homework, you better go back and look it up, right? Go back to like, parallelogram? I don't know anything about a parallelogram. Then go back in your notebook and look up the parallelogram. Like look through the theorems and corollaries and anything that mentions parallelogram, look it up. Here it's right triangle. What do I know about a right triangle? Well, I know there's a right angle. And I do know something about these angles. But it's not that they're equal, class. They'll be
equal to 90. They're complementary.
Complementary to each other. I don't know that I necessarily need that fact here, but it's a good thought to keep in the back of my mind. All right, so we've got our sketch. On the sketch, we've labeled the given parts, including those things that we figured out were given, that were kind of behind the scenes given. Does that make sense? Now we're going to start by making a long line. So take your straight edge. Oh, correction. We have to actually give ourselves a leg at adjacent acute angle. Draw a line, call it leg. Make it, inch or two. And the adjacent acute angle has to be an acute angle. Okay, so make an acute angle. Obviously, drawing an obtuse angle and calling it acute would be a lie, and a not very productive one at that. All right, so this is leg, and this is adjacent acute angle. All right, sorry. So normally on a quiz or test, this given would actually be on the paper for you. Obviously, in the textbook, you're going to have to come up with it yourself. So we draw a line, we call it leg. We draw an angle, we call it adjacent acute angle. Now we're ready to start the construction class, and we'll start by drawing a long line. Now, my recommendation on the long line would be to pick a point to be your starting point, and it doesn't necessarily have to be a vertex. For instance, this might be the starting point on the sketch, but I want to start with a right angle, don't I? Right here at this point. If I put it at the end, it's hard to put a right angle at the end of a line, isn't it? So I'm going to pick a starting point that's in on the line a little bit, and this dot is that dot. Do you see how to transition over? So at this dot, there needs to be a right angle, or class, there needs to be a
straight line.
Perpendicular, doesn't there? So let's go ahead and put a perpendicular there. There's a perpendicular here, let's put it here. Again, that assumes that you remember that if you want a right angle, you need a perpendicular. Again, I believe at this point all of you have that just fine, but do you see what I'm saying? It's assumed you remember certain things. When you draw lines and angles and stuff, go ahead and make them almost excessively large. So I don't know that I need anything quite this tall, but I'm going to go ahead and make it really nice and tall, give myself plenty of room. Notice my right angle is now constructed. And so I'm going to put a little check mark there. I don't need to worry about the right angle. It's done. All right, what else do I need to put here in the construction that is listed here in my sketch class?
The adjacent acute angle.
Well, where do I put the adjacent acute angle? Somewhere over here, right? At the other end of the leg, right? Yeah, but I don't know where the other end of the leg is. What? Yeah, let's go put the leg on there next. Before we get to the adjacent acute angle, the next thing besides the right angle right here would be the leg. So let's copy the leg and put that on the big long line. Notice we're not going to copy from the end point here. We're going to go from the dot where we started. This is where the right triangle begins. This is where I'm going to start by measuring off my leg. And now the leg is constructed. And this dot must be right there, correct? It has to be there. Now, Chris, we can copy the angle, can't we? Because now I know where the angle's supposed to go. The angle's supposed to go, and notice, the angle's supposed to go here at the yellow dot. It's supposed to face this way. So that means I need to put my angle here at the yellow dot. It's supposed to face that way. So, next class we need to copy the angle. Remember, that involves putting the point of the compass at the vertex and making an arc through both sides. Coming over here. Making the other arc. Measure across the arc. Come over here. Measure across the arc. And connect the dots. And you'll notice now that my adjacent acute angle is done. I have now constructed everything that was given. So I drew a sketch, I labeled all the given parts, I drew a long line, and I constructed all the given parts. I made a perpendicular or right angle, I copied off the leg, I copied off the adjacent acute angle. Now number 5, I got to figure it out. How do I finish this thing and turn it into a right triangle? Because it ain't a right triangle yet.
Extend the line.
Yeah, in this case, it's as easy as extend the line. It won't always be quite that easy, but here, if I just made the line longer, it would already be done. So sometimes it'll be really easy. Sometimes it may take a little bit more thought. Ooh, I just barely made my perpendicular tall enough. And there we go. I've got a right angle, a right triangle rather, given that particular leg and that particular adjacent acute angle. Simple enough. Questions on that construction. All right, you may need to flip the paper over at this point, and let's take a look at number 4. Let's take a look at number 4. And what am I constructing here in number 4, Kendall?
The hypotenuse.
That's not what I'm constructing, Kendall.
Constructing right triangle having given the hypotenuse and inner acute angle.
There we go. So once again, I'm making a right triangle, and I'm going to be given this time the hypotenuse and either acute angle. So go ahead and draw a decent length line, maybe 2 or 3 inches, because the hypotenuse is supposed to be the longest line, isn't it? So I need to give myself a fairly long line, call it hypotenuse. And then either acute angle, it doesn't really matter which one, so just draw some acute angle and call it acute angle. I'm going to draw a little bit bigger acute angle this time. I'm just going to call it acute angle. And so that's what I'm supposed to construct, a right triangle. Well, first thing I need to do once I've got all my given stuff down, class, is start by making a sketch. What do I sketch?
A right triangle.
A right triangle. And what do I know in my right triangle?
The angle in the base, like the hypotenuse.
The hypotenuse, okay? I know the hypotenuse. This line right there. I know that. What else do I have given?
Angle.
An angle. Which one? The top one or the bottom one?
Well, it doesn't matter.
Really doesn't matter, does it?
I like the bottom one.
The bottom one? I heard bottom one. Okay, let's go with this one. Acute angle. Anything else?
Right angle.
I do know the right angle.
So complementary.
I'm sorry?
So the other 2 angles are complementary.
Ah, so that means up here, this would be the complement of the acute angle that's at the bottom, right?
I have a question.
So technically I know that. Now last time it was mentioned as well, and last time I said, yeah, we really don't care about that. This time I think we will. Question?
Since it said that it doesn't matter which angle you pick, does that mean that the angles are equal?
No, it does not mean the angles are equal, because you can't just make any random acute angle and say, oh, well, if you got this acute angle, then the other acute angle's got to be the same, right? No, they must be complementary. They cannot necessarily be equal unless they were both somehow 45 degrees, if we're going in terms of degrees. Now here we've got a little bit of a problem, because to start my actual construction class, I'm going to make a long line. Normally, I make my long line as the baseline. But I don't know squat about this line.
Just flip the triangle.
So I've got 2 options. Number 1 is mentally I can rotate the triangle so it looks like this instead. Here's the hypotenuse. Here's my acute angle. Here's the complement of the acute angle. And here's the right angle. You could flip the picture. The other thing you could do is, instead of drawing your long line as an actual base, is you could draw your long line at a bit of an angle just like the hypotenuse is. It's up to you. How many say, I'd rather flip the sketch and use an actual baseline? How many say, I'd rather just make my hypotenuse come in a slanty line? We're literally split 50-50. Tell you what, we'll do the flip picture since we already drew the flip picture up here, and then next time we'll show the line at a slant instead. All right, so go ahead and draw a long line as base. And again, we're going to want to pick a starting point. Now, I'm going to X out my first picture because it doesn't work for me. So instead, this is my picture. Now, I've got an acute angle that I know. I've got a hypotenuse that I know. And if I pick this point as my starting point, both the acute angle and the hypotenuse are right there, correct? So I need to pick a point along here to be my starting point. Do you see that this time there's not really a reason not to just pick the end point? As I said, I don't have to pick the end point. How many would like to just use the end point as the starting point? How many would like to come in a little ways? All right, the end points have it, so we'll go with the end point here. Doesn't really matter though. And right there at the dot, I need to do what, class?
Perpendicular.
I have a perpendicular at my dot?
No.
I don't see, there's a perpendicular
Copy
right
the,
there at
copy
this
the
dot?
angle. Copy the angle.
No, there's an angle at the dot. Copy the angle. Do what the picture says, right? It's like watching blueprints, right? Blueprint says put a door there. Put a door there! You know? When blueprint says make the wall this long, then make the wall that long. Don't you know that? You know that? I bet if we put a porch right there, that'd be good. It says door! Okay, anyway, I don't know that much about blueprints, so I think I'll shut up now. I'm going to end up saying something wrong and people on YouTube are going to blast me for it. All right, so anyway, so yeah, there's an angle there. So copy the angle. Put the angle at the dot. Just like the blueprint or the sketch shows. Do you see the importance, by the way, of having an accurate sketch? If the sketch is wrong, your construction is going to be wrong. And I've also got a sketch in my way because I couldn't come down very far. So I'm going to erase my old sketch that we decided we didn't like anymore. Get it out of the way. Because remember I said when you draw a line, you want to draw nice and long. Last time I had to extend the line because the line wasn't long enough. So this time I'm going to make it really long. All right. And acute angle. Check. All right, now what?
Right angle. Or not right angle. Yeah, well, yeah, right angle.
Where do I put the right angle?
On the other end point.
Ooh, careful. What other end point? I don't know where the end point is. I just made this line like random length. What do I know from the sketch? Something based off of this starting point. Help him out. Anybody?
It's the adjacent.
Class. What is that? Hey, it starts at the starting point. So guess where you can put it by starting point? The hypotenuse. Measure the hypotenuse. Now I'm going to go ahead and make another little dot here to point out this is the other end of the hypotenuse. So the white dot is the other end. Hypotenuse. Check. Now, here's where we come to a problem. I have constructed everything I was given. I was given the hypotenuse, I constructed it. I was given the acute angle, I constructed it. We were kind of given a right angle, but I don't know where to put it, right? And we don't really have the complement of the acute angle. So here's where we've got to figure out a way to finish. Yes, sir?
There's only one place where the right angle could be.
Really? Where's that?
There's only one more point on there.
What point is that?
The one on the baseline.
The white dot?
Yes.
Well, yeah, but that's not where the right angle goes. If I put a right angle here, I'm in trouble. Because this wouldn't be the hypotenuse anymore if I put the right angle here.
Well, where are you supposed to put the right angle?
The right angle is supposed to be up above the hypotenuse somewhere.
So it should go at the top.
Oh, but I don't know if it goes here or here or here or here or here. Because see, remember, I just drew this line at random length. I don't know where to put the right
Measure the length.
What?
Measure the length.
What
of
length?
The sketch you
Make
made.
a perpendicular.
Oh, this sketch is just a rough sketch for reference. It doesn't tell me exactly how long that line is supposed to be.
Make a perpendicular. That one.
Ah, there's 3 ways we could finish it. Quentin, you said do what now?
Make a perpendicular line
Where?
from that line to the point.
Ah, make a perpendicular. Did you hear what he said? Not at a particular point here, because I don't know where, but from this point. There is only one perpendicular that may be drawn. Do we see that? That's one way we could do it. Let's do it that way, since that's the way he suggested. That wasn't the way I was planning to do it, but I'll take it. Open your compass more than the distance to the line, which may be a challenge. Make your arc. Come over here, make crossing arcs. And bam, that's one way to get your right angle. Frankly, I think it's probably the easiest way, Quentin. I had a couple other ways in mind that were probably actually a little bit harder. And there we go. We have a right triangle given that hypotenuse and that acute angle.
I'm glad I didn't get the option. I probably would have said something like auxiliary line or something.
Well, there
Don't tell me there's a way with
actually
auxiliary lines.
could have, in a sense, been more or less an auxiliary line. Here's another thought. Chris's suggestion all along was that this angle would be the complement of this one, right? What if I had extended the line, I'd made arcs, I'd made crisscrossing arcs, and put a perpendicular. See that this angle would have been the complement? I could have then measured that angle here, and I would have had a perfect right triangle as well. The last way is kind of a weird one. Anytime you have a right angle above a hypotenuse, you could put a semicircle on top of it, couldn't you? Had I chosen to make a perpendicular bisector, opened my compass up and made an arc, it would have cut perfectly at this point. And then I could have just gone across and I could have finished the right triangle that way. 3 different ways. The semicircle right angle method, a lot harder to think of. The complement method, which is what I expected us to end up doing. And Audrey's nodding her head, that's what you had thought of as well, was make a complementary angle. And then Gwen's like, you want a right angle? You mean a perpendicular, like from this point? Yes, not at any point. I don't know any point to put it at. From this point, construction 5 rather than construction 4. And there's our right triangle. Questions on this? I think we've got time for one more. Jump back up to number 3. Number 3. Once again, we're going to construct a right triangle. So maybe at the bottom half of the paper, or you may need a new sheet of paper by now. Number 3 on the same page, we were to construct a right triangle. This time, what are we given? Anyone? Leg and opposite acute angle. Okay, so right triangle given leg and opposite acute angle. So draw a line. Don't make it too long. Maybe inch or 2 long. Call it leg. And I'm going to go with a smaller acute angle this time. I went with a great big one last time. I'm going to go with smaller this time. I'm going to call this opposite acute angle. We have 5 more minutes. All right. So, what do I start with, class? Sketch. Make myself a right triangle. And I need a leg. Which leg should I label on my sketch? The base one. You could do either one, but again, unless I plan to draw a long line as a vertical line, which I don't want to do, I'm going to label the leg as the base line. What else am I given? The opposite acute angle. Which one is that? The one at the top. And of course, because it's a right triangle class, the right angle. All right, first things first, make a long line. And what should I put on the long line? The leg. Okay, so pick a starting point. You could go at an end, but again, as I said before, if that means you're going to need a perpendicular, I wouldn't start at the end. I'd pick a starting point that's in just a little ways. Let's measure the leg and mark it off. And I'm going to write or check off the leg is done. All right, what else do I have right here on this baseline? The right angle. The perpendicular. So let's go ahead and put a little perpendicular here. And again, when you draw this line, make it nice and long. You're not sure how long you need it to be, so make it maybe even longer than you think you need it to be. Maybe absurdly long like that. All right. Now here's the problem. I'm supposed to put this angle somewhere up here. But I don't know where up there. I can't really construct the opposite acute angle if I don't know where it's supposed to go. Thoughts? Audrey? And here's where we're going to have to do it the way we suggested last time. There's really no other way to do it. We know that down here is the complement of the acute angle, right? So with your straight edge, let's go ahead and extend this through the vertex to form the adjacent supplement. But then at the vertex, construct a perpendicular so that we can get the complementary angle to the given opposite acute angle. And we're not actually even going to copy the opposite acute angle onto the picture. We're only going to copy the complement. And we're going to copy it down here just like it's shown on the sketch. And by copying the complement, we will actually create the given acute angle exactly where it's supposed to be. And up here, you see that given opposite acute angle. A little bit of outside the box thinking here. You are going to do 4 constructions for homework tonight. For homework this evening, I want you to do pages 181 to 182. Numbers 1, 5, 14, and 16. A couple of right triangles and a couple of isosceles triangles. We didn't have opportunity to do any isosceles in class just because of the shorter time that we had today. Lost about 15 minutes or so of class, but tomorrow we'll take a look at some of the isosceles triangles. I think you can figure out how to do the homework though. Give it your best shot, and tomorrow we'll see how you did. Have a wonderful rest of your day. You are dismissed.